Since I'll be presenting on this site, Nalasopara, where many people have worked, I'm having a very, I think 7-8 pages in my hand. Because I have to present all the data because I'll never get such a platform. So I need suggestions also whatever we have done. So I'll just go through, and there are some observations on the geoarchaeological aspects. So you please pinpoint where I am right or wrong, whatever it is, ma'am. Yeah. So, Sitaram?
I think give the result.
So this is all about the geoarchaeological investigations that was conducted at ancient port site of Nalasopara in 2019 and 20. Right. So no, it's okay, ma'am. This site of Nalasopara is an ancient port site in Vasai Taluka, Palghar. So in this region, this was a port town that was situated on a creek nearby Vasai. And so it is located on the western coast of ancient site of Nalasopara near Vasai Taluka in district Palghar district. At present, the area lies between Ulhas and Vaitarna rivers, and it is surrounded by tidal flats. Having different types of environment. The region is home to numerous lakes and which are remnants of active paleochannels that once dissected the landscape like meandering streams flowing in northeast to southwest direction. So previously, various scholars have worked on various aspects of the sites. Archaeological and literary sources suggest that Sopara remained an important cultural, religious and economic center for centuries dating from the pre-Shokan period up to 3rd century AD, and again from 6th to 13th century AD. And it is then was a trading center of Portuguese. So these are the aims of the project. The geomorphological study was conducted at Sopara with the hypothesis that ancient coastal settlements were located in the most elevated areas of dynamic landscapes, such as levees of paleochannels near large and small tanks, lakes which are remnant of paleochannel network, and on the relic beach dunes. So the objective was to analyze the spatial distribution of archaeological sites and create a detailed map of the archaeological landscape in and around Sopara. Another goal was to investigate the paleogeographic conditions and geomorphologic development of the site, and to determine the relationship between various geomorphic elements and processes and their impact on the ancient settlement pattern. Additionally, the study aimed at understanding the environmental conditions based on microfossil analysis of sediments. The site of the ancient port is buried under the thick layers of silt, sand and clays, making it difficult to understand its archaeological features. To better understand the site, various methods were used, including advanced satellite imageries, aerial photos obtained by drones, topographical sheets, geographical maps, and district resource maps, and maps from Central Groundwater Board. For the survey and documentation and mapping of this site, QGIS was used. Using GIS, the entire area was divided into around 2,400 grids of 15 to 50 meters each. For the preliminary survey, 30 grids were randomly selected, and systematic collection of the artifacts was made from the respective grids. For the site examination, evaluation, mapping and plotting, and for spatial distribution of ancient sites, digital maps and satellite imageries were used. Systematic survey was organized using published sources and geomorphological information resource maps and satellite imageries. Once the site was identified, non-probabilistic sampling was conducted. In this strategy, 1 meter radius circle were laid in the areas, and the pottery collection was made. To understand the stratigraphical sequence of the site and map the ancient paleochannel networks, paleo creeks, manual auger was used at selected sites. And about 12 boreholes were taken at different areas in order to see the different types of sediment texture, composition, color, and presence and absence of cultural material. Particle size analysis was conducted at IIS Bangalore. Core samples from borehole locations at different areas were sent to Phytolithic Research Center, Pune for microfossil analysis. These samples were also subjected to calculation of phytolithic morphotypes for climate index, phytolithic index, and cold-warm ratios. Drone survey was employed at the site as a remote sensing tool. DEM, DSM, ortho images, multispectral 5-band images, contour map, etc. acquired during the UVA survey were used for site documentation, mapping, photogrammetry, and to detect buried archaeological features. For this survey, fixed-wing UAV was used with a 24-megapixel camera and 5-band multispectral sensor to acquire the multispectral images. Then coming back to geomorphology of the Nalasopara, this multidisciplinary study that was, there was a multidisciplinary study that was conducted by Dr. Savita Gati in 1988, and she assessed the geomorphological potential of Sopara site and suggested that the configurational changes played a crucial role in changing the coastal landscape of North Konkan. Our survey of the area suggests that the site is spread on 8 rows of well-defined relic dune ridges. These ridges range between 300 meters wide and 10 meters high, and 50 meters wide and 7 meter high, and are more prominent towards the southeastern side of the site. They run parallel to the present coastline for approximately 2 to 3 kilometers. Some of these ridges are occupied by modern settlements, while others are used for agricultural activities. Within these ridges, several undulations are visible towards the Stoss side, indicating dune development initiated by the wind-blown sand. The longitudinal profile of Nalasopara area along the shore shows that development of parabolic dunes due to the continued transport of sand through blowouts or branchioid relict-rich formation. These relict ridges may have formed due to active configurational changes or orogenic events or glaciation or deglaciation, or due to isostatic adjustment in the Arabian Sea. The direct evidence of shoreline shifting is evident in form of beach ridges and dune ridges present in the peripheral areas of the site. Several inter-ridge depressions of about 100 meters to 300 meters wide are also visible. Some of them are still visible as lakes in the study area. These lakes were modified during the historical period for religious purposes or subsistence. During the early mid-Holocene phase, these lakes may have been paleochannels that were connected to the creeks, as when Western India experienced a wet climate during this period, and the sea level was also higher than that of the current level. These paleochannels show several episodes of deposition and represent meandering streams separated by infill channel deposits. The landscape has mixed soil types such as silt clay, and silty clays, and has formed over the beach ridges and on the beach rock that possibly formed during the Holocene period. At several places, small patches of black fissured clays are visible, which might have formed due to ponding environment resulting from the minor avulsion due to sea level changes or subsidence of delta. At present, the tidal flat located towards the southeastern side of the site has a few creeks of 1 to 2 kilometers in length. Accretion is also observed along this small segment due to either due to constructional activities or due to bar formation at river creeks openings. Significant depositional bars are found near Nalasopara and around small creeks north of Vasai Creek. These are possible remnants of extensive coastal plains that developed along the coast, possibly in response to the slight lowering of the sea level during the Holocene. The study area is characterized by littoral terraces, which could be linked to Holocene sea level changes in the area. These terraces lie above the current sea level and occupy a back beach area bordering beaches or banks of the shoreline sectors of the tidal inlets. Sea level fluctuations are indicated by 2 or 3 generations of dune ridges that provide convincing evidence of former shorelines. The farthest dune ridge suggests the early to mid Holocene period, and these terraces are found within the elevation of 4 to 6 meters. These sea level changes were formed mainly possibly due to configurational changes during the late Holocene period. So, The surface survey indicates that the ancient settlement were established on various types of landforms. And the sediment coring was conducted at Nalasopara, and samples were retrieved from 12 different locations, revealing several factors have contributed to the geomorphological evolution of landscape. These include transgression and regression of sea levels, aeolian and lacustrine and fluvial processes, and anthropogenic activities. The data indicates that most of the ancient occupation is located on the ancient dunes or dune ridges, whereas the interdunal slags were used for some other activities, or had paleo channels or creeks filled in with fresh water. The presence of alternating layers of silty sand, sandy silt, clay lenses, beach rock, and sandy lenses, sometimes cemented or loose, with or without marine shells or with freshwater shells throughout the area, indicates a dynamic landscape that developed during the Holocene period. Analysis of the borehole data suggests that the marine sediments are present at about 4 meters above mean sea level, below the habitation soil. The highest point where the bore was taken lies above the gas lake. Beach rock was encountered at a depth of 3.90 meters. So the samples also reveal alternating marine, anthropogenic, and tidal sediments, which suggests that the sea engulfed the habitation areas and reoccupation of those areas after the regression of the sea. Pottery was also found in paleo-tidal zones, indicating that some of the human habitation zones were converted into tidal zones in the peripheral areas of the ancient habitation. Similar patterns were observed in Sanjan by Deo, Madam, and Rajguru sir. Based on the analysis of the samples, it can be concluded that the environment in and around Nalasopara area was highly dynamic in the past. Continuous sea level changes have caused lateral transgression and regression phases, leading to the development of tidal zones and estuarine environment. These changes may have been caused by configuration changes in the mid to late Holocene period. These factors have played a crucial role in shaping the development of human cultures at the site. Several studies suggest that the sea level reached at present level around 5,000 years ago and continued to rise from 4.5 thousand years to 1,000 years ago. The rise in sea level is well represented at the site of Sopara. The analysis of the samples indicates that the past environment in and around the study area was very dynamic, and continuous sea level changes have caused lateral transgression and regression phases, as well as development of tidal zones and estuarine environment. From mid-Holocene period onwards, the area has experienced continuous sea regime changes and continuous sea level rise is evident. During this period, at certain locations, alternating lenses of concretized sand mixed with small freshwater shell fragments and fine silty deposits indicative of seasonal ponding and drying of depressions and development of non-pathogenic calcrete at the junction of the sand and silt is evident. In certain areas, mid-Holocene units include marine shells, calcrete, and few chalcedonic pellets, microliths, thin, fine calcretized sandy layers with embedded marine shells, and very fine reddish lenses of sand and intercalating lenses of concretized sand with lots of marine shells indicating marine environment. However, presence of freshwater shells in the lowest unit is indicative of riverine environment in levels prior to the mid-Holocene phase. Calcrete formation and development of calcretized sand in these sediments may be a result of climatic fluctuations from arid to semi-arid type of environment at the site. Late Holocene sediments are dominated by very fine sand as well as coarse silt. These sediments contains lots of pottery, marine shells, freshwater shells, nodulo-calcrete, compact and cemented fine beach sands lenses having lots of calcareous bodies. Early historical archaeological mounds are spread in wider areas of Sopara and adjoining villages, and some of the sites are located at as high as 7 meters above the sea level. The findings from a recently dug pond near Sopara shows that early historical habitation site is buried below 1.5 meter above below the sea level and extend about 100 meters away from the site in the present mudflat area, thereby indicating active siltation of creek area due to during and after historical period. This is well corroborated with the findings which shows that late Holocene transgression reached its maximum around 2800 to 2000 BP, was almost 1 meter higher. And do we have time? Okay.
I
Okay.
want to suggest
So the analysis of the sediment indicates that the ancient habitation formed along the littoral terraces, beaches and on.
Say this is your last word. What you want to discuss with?
Okay, yeah.
No, I don't want to hurry.
Okay, okay. So this is what like I wanted to present, ma'am. There is nothing much. So yeah.
Habitation deposit 1.5 meters
Yeah.
below sea level.
Yeah.
I think this is a really astounding finding.
Yeah, and ma'am, what is happening? Like in the sections, what we have seen that there is a sandy lens and having lots of pottery in it. And again, there is an episode where lots of muddy substance is there, and again there is a sandy deposit which beach sand. So means like there are
and the
generation.
creek are
Yeah, creek.
alternating.
Yeah, ma'am, alternating. And like we can see that how these early historic deposits are getting buried under the sediments of marine sediments and in these tidal sediments. So this is something which.
We can, what I would like to suggest to the organizers that people who are here, they should present on privately.
Okay.
So now we'll hear about the tiger, and then I was informed there is one more person who will present, and there's Ajiv Srivastava is not presenting. So let us have these two papers almost within our time. And can we maybe start at 9 o'clock if you can open this room?
Okay.
And these presentations we can see before the tea time, between breakfast and the tea time. So and if there's something else left from today, we can put it in.
Okay.
But people who are here, everybody's not here for all the 2 days. They should be given priority.
Great.